In this video, I wanted to go over the exam board's requirement for us to include a physics prop and a dynamic prop. I've been banging on about it for a while, but I haven't really gone into much detail, and it can be a little bit confusing. There is also, actually, if we come back here, a requirement for props and assets, obviously. So maybe we need to look at the difference between what a prop is and what an asset is. Let's do that very quickly before we go into the differences between types of props. So we go into Blender. We've got this very basic game level here. Everything that's been created for the game is an asset, essentially. So the sound files are assets, the textures that we've created are assets, but all the game objects in here are also assets. But not only are these assets, but they are also props. So the textures and so on are assets, and then the game objects are props. If I just turn on the light in this bottom corner here, I've got little collectible objects over here. I've got a collectible object here. These are my dynamic objects, and then we've got physics props, such as these crates, which we can kind of fire a weapon at, and they'll kind of roll, they'll move out the way, etc. We'll come back to this in a minute. Let's jump back to here and look at the the difference between a physics prop and a dynamic prop. So a physics prop has some kind of physical properties. It's going to react to collisions, or it's going to detect collisions, as a better way of putting it. And we have various different types of physics that we can use within the Blender game engine. I don't really want to go through every single one of these right now. I'll put this table on Moodle, and you can have a look at it at your leisure. Essentially, these ones here are going to be the ones you're going to be using the most, I imagine. And these ones are extremely useful, but a bit more advanced. I'm going to show you a little demo of some of these in a minute. Some of them detect collisions, some of them don't. Some of them have the ability to roll around or tumble, some of them don't. So take a minute certainly to have a look at this table and decide what kind of physics props you're going to need in your game. I feel like I should point them out. I suppose the important ones, the no collision objects, are good for leaves and foliage, things that you don't necessarily want to detect collisions, but you might want to have physics properties. Static objects are completely immovable objects like walls and buildings. Rigid body has this roll quality to it, so it's good for movable barrels, crates and stuff. Soft body is really intensive for the CPU to render, but it can be used. I've seen a really good example of it used for a rope, like an Indiana Jones style rope bridge, where objects pass over it and it kind of bounces up and down. Occluder objects are really useful for optimizing your game if you want to hide part of your level behind a wall, and not have the game engine actually render what's hidden until you maybe go around the wall. Then occluder object is perfect for that. Physics props, as defined by the exam board, have these physical properties, but we also need to interact with them. It's no good having a barrel in the corner of your level that has physics properties that you don't actually interact with. It needs to have a function, it needs to perform some kind of purpose. So, for example, an object you need to move out the road so that you can continue, or something you need to move into a position to climb on to reach something else, kind of Lara Croft style, or something that falls from the sky with gravity rather than keyframe animation, which we've been using for movement up till now. So that's the physics props, really, in a very, very brief nutshell. We're going to fire up Blender and have a look at some of these different types in a second. And the dynamic prop is just something dynamic, something interactive within your game. It doesn't necessarily have to have any of these physical properties. It doesn't need to roll about. It doesn't need to fall with gravity. It doesn't need to have friction or mass, etc. But something that is actually interactive, something like a collectible or a moving platform that has an actual purpose in your game. So the static prop of my forklift truck here, although a nice part of the game level, doesn't actually form a function. I mean, it technically, I can hide behind it and so on, but it's not actually serving much of a function. I'll come back and talk about the props in here later on. First of all, let's quickly do a bit of a physics demo. So we've got some objects in our scene here. Let's have a look at the properties on them. Before we do that though, in the world settings of the game engine, we have a physics panel here. And it's using the Bullet engine. That's the physics engine that Blender uses. The main setting here is the gravity. So this is the general gravity setting for the whole world. And this is kind of going to try and mimic roughly reality, this 9.8, very specific value. If you reduce that, then obviously you're going to be floating about in space. If you increase that, then objects are going to fall through space much faster. This is really one of the best ways to speed up, if you need to speed up the way objects fall through space, increase your gravity here. When it comes to individual objects, we need to move over to the physics tab, this one here. And we can see the types of physics in this area here. So we've got this list of physics types available to us. So let's have a look at some of these. This object here is static, so it won't move, hopefully. This one here is dynamic, so we'll see what that does. This one is rigid body. And we've got the same, similar over here on the monkey heads. But let's have a look at these cubes first. So when I press play, let's see what happens to our 3 cubes. So these have just got the default settings for static, dynamic and rigid body. Static obviously stays where it is, static, but dynamic and rigid body, they fall down and they're trying to land on here, but they're going through, they're continuing on and they're going through the level. Why are they doing that? They're doing that because of this radius setting here. The radius, I'm going to talk about a few of these, but this radius one is very important. It's the default collision detection, it's the default collision boundary for this object. And by default it's a sphere. If we go into wireframe, you can see this dotted line, you can see it in the monkey heads as well. This is the radius. If I increase this, we get a bigger collision detection area. If I increase it, we get a smaller one, which is why it's landing on the edge of the radius and not the edge of the cube itself. That's the default collision bounds. So let's have a look at it again. I've got physics visualization switched on here, and we can see it actually as a white sphere on the object. Okay, so now that I've reduced this one, it's falling further. So we could, I suppose, turn up the radius on this so that it kind of encapsulates our object. But you know, a circle or a sphere is not ideal when we're detecting collisions on a cube. It's still going to stop here, I think. If we turn that back off again, you can see it doesn't quite. Oh, and it's also messing about with my rigid body object and banging it out the way. So this is not ideal. So we can override our default collision bounds by switching them on down here. And now we get a box which is a bit more suitable for what we have here. If we come back to the texture view and press play, that object now lands on the ground as you'd expect it. So let's turn that on for this one as well. And press play and you'll see they both land. However, this one is landing and sticking, this one is landing and it's kind of rolling about a little bit. That's the roll quality of our rigid body physics. If we rotate it slightly, you'll see that happening. You'll see that happening in a bit more of an exaggerated form. Okay, whereas if I rotate this one, this is going to stick on the corner. It's not going to fall back into place. So this is a rigid body, a very nice simulation of real-world objects. What else have I got in the scene? I've got this character, so let's have a look at how this character interacts with these objects. Let's just straighten them up again. So because these have physics applied to them, I should be able to move them out the way. I think if I come at this from the kind of corner, we should be able to rotate it, so you can see it sort of rotating as I bump it, whereas the dynamic one's not going to do that. And in our static object, completely immovable. So this is my forklift, or you know, a building or something. Let's have a look at some more of these settings here. Let's have a look at our monkey heads. So by default we have that radius, which is actually fine for our monkey heads. Let's just leave it. Let's just reduce it slightly In fact, we'll compare this one to this one just very quickly. And press play. You can see that our smaller radius is hitting the ground a bit more effectively than our larger one. But what other settings have we got? Let's have a look at the rest of these settings. Actor, I don't know why that's switched on. We don't really need that switched on unless, if we hover over it, tells you unless you're using the near or the radar sensor in your logic. The ghost setting is quite handy. The ghost setting will allow this to travel through, or other objects to travel through it, but it will still detect the collisions, so it's just going to fall straight through the cube, straight through the world. If we wanted to detect collisions but not have it actually render, we can click invisible here. It will become invisible, but it will still detect those collisions. I'll not go into these ones. They're not particularly useful. Mass is, the higher the mass, the more force that's required to move that object. Talked about the radius. Form factor is the likely, well, it tells you there. We all know about inertial tensors, but what it actually does is it's the kind of likelihood. The higher the value, the higher the likelihood for that object to roll. The lower the value, the less likely it is to roll. We've got linear velocity and angular velocity, so this is the max and minimum kind of speed an object, or the velocity an object can reach. Same with the rotation. Damping is extremely helpful. Let's have a look at how this rigid body object, is it rolling off our cube? Let's move it forward a little bit so that it's going to roll off the front of that cube. Go on. So it does a couple of rolls. That's going to keep going for a wee while. The damping is the drag that's applied, like the friction that's applied to the object. So the higher the damping on translation is, an object moving through 3D space. So the higher the drag, the more friction is applied to it. So we should get less of a roll. It should come to a stop sooner. There you go. If we turn it up, it's going to, I imagine, pretty much hover in space. Yeah. So that's a really useful object. So think about how much friction you want your objects to have. Let's have a look at the collision bounds on these objects. So we're using this radius at the moment by default. If we want to override that and use something a bit more efficient, we can choose different collision shapes. These are different shapes for detecting collisions. Capsule box, sphere, cylinder are the kind of default, or the sort of primitive shapes that we would use. These are going to be very useful depending on the type of object you've got, or cone. And then these ones here are a bit more advanced. Convex hull, when we turn it on, you can't see it. When we see it, if we show the physics visualization, not really. What about here? Doesn't really show it very well, unfortunately, in the visualizations. But what it does is that it convex hull ignores all of the concave areas. So these areas in here, between the ear and the bottom of the mouth, the jaw. So it will kind of create a mesh collider between the ear and the bottom of the jaw, and then back up again, and then it'll ignore this gap here. So it's trying to get as close to the mesh as possible, but saving on CPU effort, saving on the effort that the computer needs to process those calculations. Whereas the triangle mesh does make an exact duplicate of the mesh to detect those collisions, but it is quite intense. The compound setting here, we turn that on if you've got parent and child relationships with your objects and you want them to be treated like a single entity. We can turn on this compound option. I would leave the margin bounds alone. You might need to do some very fine tuning with the margins here, but really this default setting should see you through all right. What else do I need to talk about? The occluder object. So this object here is set to occluder, which means that the game engine will not render this monkey head behind it. So if you've got, as I said earlier, I think, if you've got walls and you don't want your the game engine to render what's behind the walls until you come through a gate or something and then you can see them yourself, you might want to use this. It's very, very good at optimizing your game and speeding up the frame rate. So we can have a look at that through the camera. If we go into wireframe, you can see our monkey head. If we press play, no more monkey head. So that's the occluder doing its job. It's occluding the objects behind. It's hiding them from the renderer. So that's very, very helpful indeed. Let's just have a look at some of these objects in a game setting, I think, very quickly before I go. I do not want to, I've probably already bored you to sleep, but I'm going to think positively. These crates, they're rigid body because when I shoot them, I want them to roll about. I don't want them just to move and land and stick where they are. I do want them to have a bit of a spin and a fall. So let's have a look at these in action. I think we'll test. Let's have a look through the camera. Oh, I've changed the camera on this, so I'm not used to how it works now. Let's just take out these zombies quickly if I can. So if we try and shoot some of these crates here, I'm just messing with them. I'm experimenting with this, so you can see they're kind of rolling about slightly. Let's see if I can do it. I'm not really getting into a position where the roll is. Well, you can sort of see them bumping about and rolling. So that's the the rigid body physics on those. I said earlier that the forklift is static. We have these pickup objects. The key down here is static and the little rifle here is static. So these are my dynamic props. These are objects that I'm interacting with. So this obviously gives me a new weapon. This one opens the door up here. I've got a light switch which turns on the lights. It's very dark in this corner. I've got a med kit thing which replenishes health. So these are dynamic props because they actually serve some kind of function in the game, whereas these are physics props. They have that, they're very, very basic physics props. The only function these ones are really serving is to kind of pen these two zombies in. When I play the game, they get kind of stuck until I shoot these crates out the way and then they escape. So you've got to really try and think creatively about how you can use these physics settings to create something. This is not a great example. Try and think of how you can creatively use these different physics settings. So what I would like you to do is to download this physics demo from Moodle and play about with it. I'd like you to try and, I'm going to get rid of that cube again. Play about with the character, bump things around, maybe create a little ramp and see how things slide down and change the settings. I might add a little ramp to this so that you can move these up and down and apply the different kind of damping settings, the mass, etc., and see what you can do and change the way that these objects are being simulated. Okay, I hope that was helpful. It's quite a complex kind of area to get into. That was not completely comprehensive because we do have physics settings on materials as well, so we could go into that later on sometime. We can apply physics to materials. We've got the world settings and we've got the physics on different objects. You've got lots of things to play with, but really concentrate on what is going to be a prop within your game that serves some kind of function. Okay, thank you very much.